When it comes to triangle congruency theorems, there are 5 different theorems to remember. Angle, angle, side, angle, hypotenuse, leg, side, angle, side, and side, side, side. Okay, here's the first example. The first thing you should notice is the reflexive property. Because there is already another side and an angle marked, the reflexive property will prove that this is hypotenuse leg. If the triangle was marked with the letters A and B, the reflexive property would essentially look like line segment AB is congruent to line segment AB, which is how it should be explained. This pair of triangles is missing vertical angles. Vertical angles are always equal. You can reference a set of parallel lines cut by a transversal to see a different representation of vertical angles. This would show that the triangles are congruent by side, angle, side. These are missing vertical angles, so it would be angle, side, angle. This is not angle, angle, side because the side is separating the angles. The angles are not directly next to each other. The next example is also missing vertical angles, but these are congruent by angle, angle, side. This side is not separating the two angles. And these triangles have the reflexive property, so they would be a simple side, side, side.
When you first look at number 6, you should notice that there are vertical angles. After you mark those, you can prove that this pair of triangles is congruent to this side angle side congruence theorem. Just like the previous problem, number 7 is also missing vertical angles. Once we have marked those on each triangle, we can prove that the triangles are congruent through the angle-angle side congruence theorem. In number 8, the reflexive property is missing. When we mark this and notice each triangle is a right triangle, we know that these triangles are congruent through hypotenuse leg. We know this is hypotenuse leg because one leg and the hypotenuse of each triangle are congruent. Right triangles wouldn't be congruent through HL if only the legs were marked.
Hopefully it's safe. Yeah. Hopefully it's safe. Did it save? Yeah. Okay, hopefully it did.
Oh, I know it did. It saved on that.
Okay, good. Because I will panic if all of a sudden you're like checking and editing it and all of a sudden it's not there anymore. Because then it's like, oh.
In number 9, the reflexive property is missing. Once marked, we can prove that these triangles are congruent through the angle side angle congruence theorem.
Yeah.
In number 10, the reflexive property is missing. Once marked, we can prove that these triangles are congruent through the side 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 congruence theorem.
Now we're going to look at triangle congruency theorems and proofs. Line segment AB being parallel to line segment DE is given, and C being the midpoint of AE is given. Angle BAC is congruent to angle DEC because if you look at them, they are on opposite sides of the transversal and are inside of the parallel line, so they are alternate interior angles. Angle C splits line segment AE in half, so C is the midpoint, making this the definition of midpoint. Angle ACB and angle DCE are vertical angles. And after marking all of these, you should be able to tell that this is angle side angle. Lastly, you are trying to prove that BC is congruent to DC, so it is CPCTC.
It's obvious that number 1 given is line ST is congruent to line VU. And TV is congruent to TV, making that the reflexive property. Triangle STV is congruent to triangle UTV. Therefore, the congruence theorem is hypotenuse leg. And those two angles are congruent, so number 4 is CPCTC.